Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through some of the major topics facing importers and manufacturers in China today. Hi listener, welcome to episode 36 of the podcast. Adrian from Sofeast here, and joining me is our CEO, Renaud and Adrian. Today we're discussing everything about product reliability testing. These days it's more important than ever that importers cover themselves against problems that are going to cost you money, damage your brand, and potentially get you into trouble with regulatory bodies in your country where you're importing your products to. If we're testing our products for reliability at an early stage in the production process, this means that we're going to make sure that the product is as reliable as possible and will work as intended without failing for the expected length of time. So that's probably your warranty period. If a product is not reliable, you're going to be faced with potential lawsuits, expensive recalls, and other unpleasant issues for your company. So let's dive into a very, very thorough episode which explains what kind of testing you're going to do to assure product reliability, lots of great examples, and even a good idea of how much it all costs to put together. Okay, let's get started. Hello again, Renaud. Thanks for joining me. How's it going?
Hey, not bad. How about you? It's getting a bit cold here, actually. South China, but you know.
Cold.
People don't
Define
realize
cold.
that sometimes, around 8 to 10 degrees, but there's no isolation, there's no heating. You know what it's like.
Yeah, it does get quite cold when you're inside. Actually, you're very right. But yeah, I wish it was 8 or 10 degrees here in the
UK. Yeah.
There are some quite important topics that we've been speaking about recently, and one of them is product reliability. Anybody that's familiar with the website has probably seen that we provide product reliability testing and other related services, certainly with packaging as well.
Mm-hmm.
And so with today's topic and 2021 and onwards, product reliability is really a key concern for importers. Right. So what is product reliability in a nutshell? Can you explain that?
Basically, a product is reliable if it works. But it's not just working right now. It's working for the duration that it's supposed to work. So if a company manufactures a product, say in Shenzhen, ships it, puts it in the hands of some users, and gives them a warranty maybe of 2 years, well, you better keep working for 2 years with a very high probability, right? And maybe the target should be 3 years or even more. And it's not just working for a certain time, it's also working, for the users as they're going to use the product and in the operating environment and the kind of use, right? So it really requires both knowing the product and also knowing how the users are going to use it and even abuse it, I might say. So if it's a pair of shoes, then you kind of have to simulate. Maybe you're afraid that the soles are going to get used up too fast. Maybe you simulate a certain amount of, I'm looking for the word.
Wear and tear?
Yeah, basically wear and tear, yes. If it's, I don't know, if it's a razor, it's going to require, and maybe a razor to be used by women in the shower, then you have to think, is going to be in contact with the skin and perspiration, is going to be in contact with soap and shampoo and things like that, is going to be definitely in an environment that is warm and humid at times with a lot of cycles. If it is a some kind of electronic product, I don't know, let's say a smartphone, there's a lot of things to get right with a smartphone. If it drops, if it's not too high, of course, it's supposed to keep working. Even the display is supposed not to break, right? If it's left out in the cold, if it's used by people in Norway or in Siberia, is it still going to work? There's a lot of things that go into it. So it really requires knowing the product itself and how it's supposed to be used, and also how it will be used, really.
Interesting. And if a product is not reliable, what is going to be the effect on you, the importer of this?
Well, returns, maybe warranty returns. If you sell, for example, on Amazon or something like this, you might get a lot of bad reviews. And if it is, what might be called a catastrophic failure that leads to safety issues, well, there's basically no limit. You might have to recall a full batch. You might have to answer some very uncomfortable questions, in a court of justice. You might have to pay some very heavy damages, especially in the US. It's like, there's no limit on the exposure to those kinds of damages. So what might go wrong is, everything basically.
Right,
It's something not to
good.
be taken lightly.
Okay, so with that in mind, I mean, what would you say typically causes reliability issues in a new product?
So usually we break it down into different families, let's say, or categories of causes, right? So a big one is design, the design of the product. And when you talk about reliability testing, design is usually the number one cause. Poor design, what some people might call design defects, or what do they call it? Design weaknesses. Yeah, usually the standards, the military standards that are still very heavily mentioned in reliability testing studies and failure analysis and all these kinds of disciplines mention. They call it design deficiencies or design weaknesses. So what does it mean? Maybe the wrong material was used. Maybe they tried to remove some protection and they removed too much, right? So, for example, you might remember the Samsung Note 7, was it? Yeah, that was catching fire and so on. Well, so it was a very serious safety hazard. Now, what caused it? Poor design that led to reliability issues, that led to safety issues. They tried to remove what they call the packaging, the packing of the battery, which is what sort of protects the battery pack. And then if it fell down in a certain way, then it could lead to, I guess, short circuits and things like that. Certain parts of the battery to get in contact where they should never be in contact. So design is a very, very big thing. Then there's manufacturing, and it can be manufacturing of the components or manufacturing at the final assembly site. And that has an impact on who is responsible, because sometimes the buyer, the brand will say, you have to buy this component from that supplier, and then that supplier does a bad job manufacturing its components. Who's going to be on the hook? The final assembly guys? No, it's the brand actually carries a responsibility, and of course the component supplier. So I mentioned manufacturing issues from component suppliers or from the final assembly manufacturer, right? And of course, manufacturing issues do have an impact. For example, if you specify the wrong kind of glue, and then that glue over time, in the sun, with humidity, and simply with time passing, stops really binding the materials together, well, the product is going to fail. If you specify the wrong kind of glue, as I say, that's a design issue. If you purchase the glue from a supplier that was really not really qualified to have any kinds of good process controls in place, well, that's, you might say it's a procurement issue or it's a manufacturing issue. Anyway, it's not really a design issue, and that happens a lot, by the way, with when there's glue that's involved. But it's just an example. Just an example. Another example, very typical in electronics, because we talk a lot about reliability in electronics, might be that in the PCBA process, well, the solder paste is left to get dry before it goes into the reflow oven, because just because the parts have to wait. And then what does that do? You might really notice it when you assemble the product and you test the product, but then 3 months later, after all the vibration of transportation, well, maybe 20% or 30% of the product stop working. They just don't work. And then everybody in China is going to say, oh, but it was working fine. Look, we did all this testing, we have all the data and so on. It worked fine. But the buyer is going to say, or maybe the customer of the buyer is going to say, I don't care. 30% of your product is not working. Look at that. I don't want that batch. It's terrible, right? So that's where reliability testing starts to be important. If the final assembly manufacturer had conducted some vibration testing, and there are some relatively simple, pieces of equipment that do that. We have one, and we do it pretty often typically on a full carton, because then you also check the effect on the carton, and you really simulate transportation. But that's a very common failure mode for electronics. Vibration and also high heat. High heat simulates the accelerated life to a certain extent, and you can catch a lot of issues that way. And so this is basically a way of catching these issues rather than putting products on the market that might be working well right now, but that might not work in 3 months or 12 months, right? So, sure. And reliability testing is kind of a deep topic. It can be done in many stages of production and development, but that just to give you an overview, basically.
Yeah, sure. And I suppose with today's access of the internet for the end users, it's more important than ever to make sure that products, even maybe cheaper products, are really going to last the course, because of course, as soon as they start to fail, the consumers are going to go on the internet and give bad reviews, etc. And this is really damaging, right?
Yeah, yes, if it stops working and stops being useful, and even worse, if that might lead to safety issues. So
absolutely.
Think of any products, for use with babies or with batteries, or something as simple as going to Starbucks, getting your latte to go in a paper cup. Well, imagine if for some reason the paper cup, maybe the bottom would fall off, and then you're driving and you get all of this super hot coffee onto your lap. That is a very serious safety issue, right?
Sure.
And you can think of that for many kinds of products. The same thing can happen, or worse. Cots for babies, or what is it called, strollers. There's all kinds of like crazy, terrible scenarios that, if they happen, can really endanger the baby's life. So you need to basically, if you design that product, if you want to develop that product, well, number one, you have to understand the safety standards, because you're not the first one to make that kind of product, and there's probably been a lot of issues in the past, and regulators have tried to put standards in place to catch these issues, to at least to make it very clear that it's it is a very serious problem, and and this is what's required, right? So you have to be familiar with that. That's step number one. You have to think of your specific product. What are the terrible, catastrophic scenarios that that might happen, and you need to review your product to make sure that all of these catastrophic scenarios are basically impossible or as unlikely as possible, right? This is really step number one. Step number two, if you design one of these products, that if something goes wrong, could lead to life or death results.
So let's say you're a hardware startup and you're creating a new product, and you are new to the whole process of looking into potential reliability issues and catastrophes that you've mentioned. If you work with a company that provides the reliability testing in a laboratory and has that experience, are they likely to be able to give you advice on what you should be looking for?
Yes, to a certain extent. However, as I said, it's extremely important to know your users and to know how they will use your product, in what conditions, what manners, in together with what other products and so on, and how they might misuse it. Okay, this nobody should know it better than you. If you design your own product, you get to be in the heads of your target users. There's really no excuse not to be able to plan for that. But yes, of course, we give a lot of feedback, and we ask some questions to prompt our clients to think of that. When we see that they've been developing a product, and then we ask about this and we ask about that, and do you know about the applicable regulations on this? Have you thought of that very specific case that seems pretty horrible? And if they don't have questions, well, that sends them back to regulations analysis and to market research and really to think of the design of their product, right? I mentioned risk analysis before. Design FMEA, that kind of approach is useful because you really go through, okay, what are the worst things that can happen? If they haven't done that, and if we see that there's really something missing, then that's something to cover. But again, together with the client, the company developing the product. Otherwise, there's a lot of things that might be missed here. If they've been developing their design and they have prototypes, we kind of challenge them. Okay, so what exactly do you want it to do? And okay, so what does that mean exactly, and how to test it? And so they might say, I don't know, I want I don't know, headsets. Okay, headsets. It's a very popular product these days, and they say, okay, we got to be able to listen to music for 50 hours. I'm saying random numbers here. Then we say, okay, well, that can be tested, but of course you need to say what kind of volume, and you need to maybe tell us what songs and what kind of music, be as specific as possible. That's one thing that is to confirm performance. However, to work towards having a more reliable product, you also want to push the limits, and pushing the limits, really to push the product to failure, will show you what the weaknesses are of their design, right? So you put the volume much higher, you do certain things. Actually the headphones, that's not a great example, but let's say an e-bike. If they say, well, it's got to be able to go on the road and at a certain speed, then you go, okay, then what about on a really bad road, with a lot of potholes and things like that, and what about with inclination going uphill, and what about at extreme temperatures, and what about with 150 kilos on it, And what about, you go, people usually call it accelerated lifetime testing, but it can be more or less scientific. Accelerated lifetime testing usually tries to simulate the typical use, but just accelerated by making things harsher on the product and doing a lot of cycles. If you don't do it in a very scientific way, it's still good to just go, think of overloading everything and see what fails first. And that is probably the main weakness of your design. And then, people can, if the results are kind of bad, and if it's worrying, then people have to get back to their design and make some changes, right, to the product design. So during the development, there's a lot of things can be done. Now, when you go into mass production, it's really a different approach. You typically, let's say there's tooling involved, and then for example, you have your casing made by plastic injection molding, and you have maybe some electronics inside and so on. Okay, you start to do a very small build, a pilot run, a pre-production pilot run, we call it, and then these samples, typically you will also want to do some compliance testing. Okay, we already covered that in a previous podcast, but
yeah,
you can also use them for some reliability testing. And here, what you're trying to do, you don't really want to push them to failure. You just want to confirm, hey, everything okay here? Because maybe on prototypes, you sort of validated the product design, doesn't come with very serious weaknesses. Now, with these products, these maybe you made 50 pieces, 100 pieces, you subject them to a simulation of a typical usage for, I don't know, for example, for 2 years. And then you just see if it passes or not. It's more like qualification testing, right? If it doesn't, then you have to wonder, well, what went wrong here? And it might be an issue with the way it was manufactured, right? And that is really important. It's really good to find out about that now, rather than after you have, you've had all the parts made for 10,000 pieces, and you've assembled everything and you've shipped them to customers and so on. There is still an opportunity to look at the manufacturing, see what might have triggered that, and then go back into another pre-production pilot run and retesting to confirm that these issues have been fixed. So it's always it's so expensive to make an entire production batch that has issues and ship it to customers, and maybe loses customers, plus have a lot of penalties or damages to pay, and so on and so forth, and lose reputation. So on. It's so expensive that is really a very good idea in the vast majority of cases to slow down a bit and do this type of validation. It's very common when you look at the way big companies that have been doing that for 30 years do it. That's just part of the way they do business. So why should smaller companies do differently? They want to take much higher risks. Sometimes there is a business case for that, but in many cases, at least they should be aware of the risks. And in many cases, they are not.
Yeah, it's almost hard to believe that a company would take that risk and just roll the dice and put products on the markets that haven't been tested for ultimate reliability.
There are so many companies launch products these days, but it's their first product, the second product, or the third product. They don't have much experience in that. They tend to place a lot of confidence in the manufacturer. Hey, it's a coffee machine, and these guys make coffee machines every day. What's so hard about that for them.
Yeah.
Yeah, but the design is a bit different, so there's a host of potential issues that haven't really been tested, and you are taking high risks. However, if you haven't seen the kinds of problems that can come up, well, you don't have them in mind, and you don't plan for them, and you make it possible for them to hit you, and and then it's too late, right? It's too late.
Yes.
You can't really do anything about that.
Yeah, you're right. Okay. Just a little bit earlier on, I mean, you've just been speaking about, the importance of doing this testing in the pre-production sort of stage, right? I'd like to move on to talk about the testing in particular. Earlier on, you mentioned a little bit about the accelerated lifetime testing, also some vibration testing. I mean, can you give us a flavor of the kinds of reliability tests that would normally be done? And I do understand that this would vary quite a lot depending on the type of product, but still,
Yes,
you
it
know what I
would.
mean, right?
Right. Yes, it would. I talked about electronics. The most common types of tests would be cycling the product, from low to high temperature, back and forth, and also with high humidity and low humidity, just to see how that impacts the electronics. Maybe salt spray testing, just to check if the metals that are exposed will get corroded, will get rusted easily or not. There are more mechanical simulations, just dropping the products, putting them on the vibration device. If there's a cable, maybe flexing the cables for, I don't know, 1,000 cycles. There's all kinds of things like this that can be put in place. Some of them are more life cycle simulations. So, for example, if there's a button on the product, well, how many times is the button supposed to work, right? So if it's supposed to be pressed 3 times a day for 3 years, you do the calculation, that's that many cycles, and you can have, a tester actually to press that many cycles. Same thing with cars. You have robots that open the doors, close the doors, open the doors, close the doors, sometimes strong, sometimes with a light pressure. And then you look after and you say, well, how is it resisted that? Is it feeling a bit different here? Any degradation, or the look and feel is still okay, right? And there's all kinds of things like that. When there's a motor, maybe some cycles on, make it work for a while, turn it off, or packaging, and that's really applicable to pretty much all consumer products. You package them fully, and then you subject them to basically a simulation of what they might experience, what they might suffer during transportation and warehousing. So they might be dropped. There are going to be a lot of vibrations in the trucks and so on. They are going to be compressed. The imaging cartons at the bottom of the container. How many kilos are they going to have on them, right? So these kind of things can be simulated in a factory or in a lab really easily. And that's how importers, try to limit their exposure on damages on packaging. Because if the packaging is damaged, well, the product itself might be damaged, and maybe the packaging itself is part of the retail experience, and then you cannot sell the product at all. Or e-commerce, right? Packaging is quite important for a lot of products. It's part of the product, actually.
For sure.
For batteries, for batteries, very often it's at the same time reliability testing and safety testing. if you force some short circuits on the cell or on the wool pack, um, you let them fall on the ground. You do thermal abuse, thermal shocks. Even you crush them. You overcharge them. You discharge them fast and completely. There's different things like that you can do to really confirm, okay, these batteries are fine. We're not gonna run into a lot of problems here, right? So that's an example. I talked about electronics because that seems to be the kind of product, at least that we work on, that require the most attention when it comes to reliability testing. However, as I mentioned at the beginning of the podcast, really, you can think of reliability testing for any kind of product. Basically, a product that's going to be needed, to do something, to perform certain functions, not to break, not to disappear. I don't know how to say it, but you got to think of what is going to happen to it, what it has to withstand, and then you just replicate it. That's the basic logic here.
So when we speak about replicating some of these problems, and you also mentioned a really famous example, which was the Note 7 fiasco is the only word for it, which was the exploding Samsung phones earlier on. I mean, when we've been doing this reliability testing for different customers over the years, what have you seen that's been uncovered that you thought was, wow, that's quite surprising or shocking, or have you actually seen any examples that reliability testing has brought up?
Oh wow. Products that just catch fire. That's the most scary thing. Usually we do that in a lab because then they have all the how to say, the protections and things like that. If we do that in our facility, who knows? The day after there's a government safety inspection which happens from time to time, and they say, oh, did you burn something here?
Is your insurance up to date?
I mean, it's in China, they're very, very, very serious about that. Very serious. Yes. A lot of people have been trapped and burned to death, and they don't want that to happen. So actually, it's a good thing, but they're quite strict. All kinds of things, just products that you test and just break, or you test the surface and it just gets corroded pretty fast, or the plating is so thin and the adherence of the coating, typically the plating is so bad that it just goes away. I mean, it's all kinds of things. I'm trying to think of the most shocking ones. I'm not sure about that, but yeah, things that take fire. This is the most scary.
Yeah, well, and a good example of that, I suppose, recently was the hoverboards, wasn't it? I mean, those all came from China, and they were sort of portable exploding devices as well, weren't they, because of the batteries in them?
Oh, the news are full of these kind of things. Again, the Samsung Note 7, the overboard. When you think of safety issues, I mean, let's be clear. The products that are put on the market are not supposed to be unsafe, right? They're supposed to behave in a certain way and not do certain things.
Yeah.
However, when they do something wrong, like catch fire and so on, this is usually because of reliability issues. Because in certain cases, when something happens, then what is not supposed to happen does happen. Right there, that's reliability. So most of the really scary examples in the news are actually at the heart reliability issues.
Right. And that actually brings me on to my next point, was that in the past you've written about the link between reliability, quality, and safety. And I mean, that's exactly what you've just been talking about. When these safety issues have occurred, which is something set on fire, that's not safe. Actually, we trace it back to a reliability problem. So, I mean, how do the three concepts of reliability, quality, and safety overlap for you?
Basically, okay. Safety is sort of the end result of problems from the user point of view, and that's when it's a user safety issues is a very, very serious problem. Okay, but that's sort of the impact, right? And if we simplify this, we'll say that if a design itself is not reliable, and if manufacturing is not done consistently, and that's more, let's say, quality, that's very much the focus on quality. If one of these two or these two go wrong, then that's when safety issues are allowed to pop up. Thinking, all the reliability engineering, the risk analysis, and so on the design really, focus on the design, picking the right materials, putting the product together the right way, and so on. That's the main focus of reliability. That's done during the product development, the new product introduction process. Then you start to think of how the final product is going to be tested and accepted, and how it's supposed to be manufactured, and so on. And then you watch carefully over how manufacturing is done, and you test the components, and you test the products, and so on. That's the focus of quality. And if both of these are done very well, there should not be safety issues.
Right.
That if I summarize things, that's really the logic here.
Yeah, great. Okay. Yeah, makes a lot of sense. That's really helpful. And to round off the episode, I'd like to get an idea of how much the sort of reliability testing that you've been discussing with me today actually costs. And I know this might depend on a lot of factors, but maybe you're able to give some sort of examples that can give us a ballpark figure?
Well, I mean, typically for most consumer products that are not supposed to be made in very large quantity, it would range between, let's say, I don't know, between $300 and $3,000 to do it right.
Right.
Again, it's a one-off investment just to make sure that your product, which might have a life of 5 years, is going to work as expected, as long as it's made the right way, right? So a lot of companies try to skip that, but actually, when we explain, if we do this, we'll cover that risk, and we give a few examples of things that might go wrong. Usually, people who've been designing their own product, they get pretty scared, and they really want to test to make sure it doesn't happen. So yeah, in these cases, people will do something usually. They will do risk analysis. They will pay for some testing. Yes. And obviously, if it's if it's a car, a rocket, or just an iPhone, it's many times more expensive. But that's not what we're covering here.
Right. Yeah. But the cost, though, that surprises me to an extent. I don't think that's particularly high investment for anybody that's developing the sort of product that we've been discussing. So to sort of skip that process, unless, let's say, maybe your supplier has encouraged you to just move on, and that they've got it, and maybe they don't actually have it, it just seems that it doesn't have a lot of sense to skip it.
That's what we tell them every time. And we really have to push them to do it if we're going to be the manufacturer of the product, because we might do a great job on quality, but then if there are returns because of a poor design, because the users, the way they use it, have some issues with it, nobody's going to be happy. And some customers don't understand that it's due to the design. So it's much better to do a good bunch of testing and get, make the weaknesses appear so everybody knows about it, and then they decide if they want to iterate on the design, or if they're happy with the risks and they want to go into production. But at least everybody knows about it, right? It doesn't uncover all the risks, obviously, but it does uncover some of the risks usually, and that's a good thing. Yeah, usually, I mean, it's always a good thing.
Yep. Okay. That's 100% clear. So basically, get your reliability testing done. Don't take the risk.
Correct. Yes. And for, I don't know, for garments, or, there's a lot of product categories where it doesn't really apply. If it's a pair of jeans, well, you could, of course, you can test, the wear and tear and things like that. But maybe users like it if it gets degraded fast, and there's in some cases you don't really want to do reliability testing, right?
Sure.
Certain kinds of furniture also are in that category. I mean, or decoration products. So it's not for every product, obviously, but it does apply to a lot of products.
Great. Okay. Well, thanks very much for filling us all in on that. That's been a really informative episode this week. Really enjoyed recording this one. And you've mentioned so much stuff throughout, so I will add a number of links to related information, blog posts, podcast episode videos to the show notes. So if you're listening, just make sure you have a look at the show notes. And with that, until next time, Renaud, and also for the listener, we'll see you soon.
All right. Yes. See you soon. Thank you.
Thank you.
Thanks for joining us. If you've enjoyed today's podcast, don't forget to like and share, and you can subscribe on Apple Podcasts, Spotify, and all other places that you get your podcasts from. See you next time.